Gamma-ray bursts are the most violent explosions in the universe, and one of them could end civilization as we know it in a matter of seconds. These cosmic monsters release more energy in 10 seconds than our sun will produce in its entire 10 billion year lifetime. On October 9, 2022, at precisely 14:21 GMT, something extraordinary happened. A cosmic explosion from 1.9 billion light-years away slammed into Earth's atmosphere with such incredible force that it activated lightning detectors in India and saturated the most sensitive gamma-ray instruments in space. For 7 minutes, high-energy photons from what astronomers now call the BO-T, the brightest of all time, toasted one side of our planet as never before observed. And this was from nearly 2 billion light-years away. What would happen if one of these cosmic monsters went off in our cosmic neighborhood? The story of gamma-ray bursts begins with Cold War paranoia. On July 2, 1967, at 14:19 UTC, American Vela satellites detected a flash of gamma radiation unlike any nuclear weapon signature they'd ever seen. These satellites were designed to catch the Soviet Union cheating on the nuclear test ban treaty, but instead they stumbled upon the most powerful explosions in the universe. Ray Clabasettle and his team at Los Alamos spent 6 years analyzing the data before they realized they'd discovered something far more terrifying than any human weapon. Gamma-ray bursts are cosmic lighthouses of death that come in two distinct varieties. Long-duration gamma-ray bursts occur when a massive star, at least 20 times more massive than our sun, runs out of nuclear fuel and its core collapses into a black hole in less than a second, through what scientists call the collapsar model. Unlike these stellar death explosions, short GRBs last under 2 seconds and come from neutron-star mergers that create kilonova explosions. Both types channel material through powerful magnetic fields toward their poles, shooting jets of superheated plasma into space at 99.9% the speed of light. These relativistic jets contain gamma rays, the most energetic form of electromagnetic radiation, along with an intense spray of electrons and positrons. But here's what makes them truly terrifying. These explosions focus their destruction. Unlike supernovae that blast energy in all directions, gamma-ray bursts concentrate their fury into narrow beams just 2 to 20 degrees wide. It's like the difference between a flashlight and a laser pointer. This focusing effect means that if you're in the path of the beam, you receive a concentrated dose of cosmic destruction that defies comprehension. Dan Perley, an astrophysicist at Liverpool John Moores University, put the energy scale in perspective when studying the BO-T. There is nothing in human experience that comes anywhere remotely close to such an outpouring of energy. Nothing. Eric Burns from Louisiana State University was even more direct. The energy of this thing is so extreme that if you took the entire sun and you converted all of it into pure energy, it still wouldn't match this event. Currently, orbiting satellites detect about 1 gamma-ray burst per day, somewhere in the observable universe. The Burst and Transient Source experiment, aboard the Compton Gamma Ray Observatory, detected about 1 GRB per day throughout the 1990s, building the foundation for our modern understanding of these events. But thankfully, all observed GRBs have occurred well outside our Milky Way galaxy. For our galaxy, estimates suggest a long-duration gamma-ray burst occurs somewhere within it only once every 10,000 to 1 million years. But here's the chilling calculation. Every 5 million years or so, a gamma-ray burst goes off close enough to affect life on Earth. Since Earth formed 4.6 billion years ago, there have been roughly 1,000 such events. The danger zone for a gamma-ray burst is terrifyingly large. A GRB could potentially vaporize anything in its beam's path within 200 light-years. But even at greater distances, the effects would be catastrophic. If a gamma-ray burst occurred within 5,000 to 8,000 light-years of Earth and pointed directly at us, the consequences would devastate our planet's ecosystems. Let's walk through what would happen if Earth found itself in the crosshairs of a nearby gamma-ray burst. First, the good news. There would be no immediate surface effects from the gamma rays themselves. Earth's atmosphere is remarkably effective at absorbing high-energy electromagnetic radiation. The initial burst would only cause a brief increase in ultraviolet radiation at ground level, lasting from less than a second to tens of seconds. But then the real horror would begin. Gamma rays cause chemical reactions in the atmosphere involving oxygen and nitrogen molecules, creating nitrogen oxides. These compounds would tear through our planet's ozone layer like acid through paper. Models show a gamma-ray burst could cause a global ozone reduction of 25 to 35%, with some regions losing as much as 75% of their protective ozone. This destruction would last for years, and the ozone could take up to a decade to fully recover. Without the ozone layer's protection, deadly ultraviolet radiation from the sun would flood Earth's surface. The increase in UV radiation could cause up to 16 times the normal levels of DNA damage. But the devastation wouldn't stop on land. Ocean phytoplankton, which account for up to 40% of the ocean's photosynthesis, would suffer harm at depths of up to 75 meters, with research showing 20 to 60% of these microscopic organisms could be wiped out. These organisms form the foundation of marine food chains, and their destruction would trigger a cascade of extinction across the planet's oceans. The effects would be swift and merciless. A 10-second burst would strip Earth's atmosphere of half its ozone almost immediately. Since gamma rays travel at the speed of light, there would be no warning of the incoming disaster. One moment, life would be thriving. The next, half the planet would be sterilized by deadly radiation. Some scientists believe this has already happened. About 445 million years ago, during the late Ordovician period, Earth experienced one of its most severe mass extinctions. Roughly 85% of marine species vanished in what paleontologists call the late Ordovician mass extinction. The pattern of this extinction puzzles scientists. Species that lived near the ocean's surface were decimated, while deep water creatures survived in much greater numbers. This is the opposite of most extinction events, where widespread species typically fare better. Adrian Mellett from the University of Kansas and his colleagues proposed a chilling explanation: a gamma-ray burst. The evidence fits remarkably well. Surface-dwelling organisms would have been exposed to the increased ultraviolet radiation following ozone depletion, while deep-water species remained shielded. Brian Thomas from Washburn University calculated that there's a 50% chance that such a lethal GRB occurred within about 6,500 light-years of Earth during the last 500 million years. But could it happen again? For years, astronomers worried about a star system called WR104 located about 8,000 light-years from Earth. This system contains a massive Wolf-Rayet star locked in a deadly dance with a companion star, creating a spectacular pinwheel structure visible through powerful telescopes. Peter Toothhill from the University of Sydney, who studied the system extensively, captured the fear perfectly. I used to appreciate this spiral just for its beautiful form, but now I can't help a twinge of feeling that it's uncannily like looking down a rifle barrel. The concern was that WR104's rotational axis appeared to point roughly toward Earth. When the Wolf-Rayet star eventually explodes, which could happen within the next few 100,000 years, it might produce a gamma-ray burst aimed directly at us. But recent observations from Hawaii's Keck Observatory have provided relief. Astronomers now believe the system's orbit tilts 30 to 40 degrees away from Earth, sparing us from a potential cosmic execution. Still, WR104 represents the kind of threat that exists throughout our galaxy. These stellar time bombs scatter across space, ticking toward their inevitable explosive ends. And when they detonate, they could reshape the biological history of any world unfortunate enough to be in their crosshairs. The BOAT event of October 2022 gave us a preview of what a closer gamma-ray burst might unleash. Despite occurring 1.9 billion light-years away, this explosion was so powerful that it disrupted Earth's ionosphere, the electrically charged layer of atmosphere that reflects radio waves. Mirko Piersanti from the University of L'Aquila in Italy, who studied the event's effects, found that the burst caused measurable changes in our planet's electromagnetic environment. Eric Burns, who led the analysis of the BOAT, emphasized just how extraordinary this event was. GRB 22-9A was likely the brightest burst at X-ray and gamma-ray energies to occur since human civilization began. The explosion was so intense that it remained visible to amateur astronomers for hours after the initial burst. Statistically, a gamma-ray burst as powerful as the BOAT hits Earth only once every 10,000 years. And remember, this one was from nearly 2 billion light-years away. The question isn't whether gamma-ray bursts pose a threat to life on Earth. It's when the next one might occur close enough to matter. Fortunately, Earth enjoys a relatively safe position in the cosmic neighborhood. We orbit a stable star in the outer suburbs of the Milky Way, about 28,000 light-years from the galactic center in the Orion Arm, where massive stars and violent explosions are far more common. There are no known stars within 200 light-years of Earth that are destined to produce gamma-ray bursts. Our galaxy's composition also works in our favor. The Milky Way is metal-rich, meaning it contains many elements heavier than helium, and gamma-ray bursts occur less frequently in such environments. Andrew Levin, who studies GRB environments, explains that this chemical richness provides a natural protection against these cosmic disasters. But what if we weren't so lucky? What if a gamma-ray burst did target Earth? Could humanity survive such an event? The prospects are grim, but not entirely hopeless. Milan Cherkovich and Branislav Vukotic calculated that to survive a direct gamma-ray burst hit, humans would need to shelter in bunkers at least 3 kilometers underground. Such depths are achievable with current technology. Submarines can already withstand the pressure at such depths. Alternatively, the safest place might be under the ocean itself. Submarines could position themselves in parts of the ocean where the gamma-ray source is blocked by Earth's bulk or near the horizon, effectively increasing their protective depth. The ocean would provide excellent shielding from both the initial gamma radiation and the subsequent increase in harmful ultraviolet light. Some locations might be naturally protected. Adrian Melot points out that places like Europa and Enceladus, moons of Jupiter and Saturn with oceans beneath ice shells, would be nearly immune to gamma-ray burst effects. The ice would provide natural shielding from the radiation, preserving any life that might exist in those subsurface oceans. As we continue to study these cosmic monsters, new discoveries keep emerging. In 2024, researchers analyzing the BOAT found the first high-confidence emission line ever detected in 50 years of gamma-ray burst studies. Maria Edvigi Ravasio, who made the discovery, described her reaction: "When I first saw that signal, it gave me goosebumps." This finding helps scientists understand the complex physics of these extreme events and the structure of their relativistic jets. Gamma-ray bursts represent both the universe's incredible beauty and its capacity for destruction. They're cosmic lighthouses that can be seen across billions of light-years, yet they're also harbingers of extinction that could sterilize entire worlds in seconds. They remind us that Earth exists in a dynamic, sometimes violent universe, where the actions of distant stars can reach across space and time to influence the course of life itself. The late Ordovician extinction may have been caused by such an event 445 million years ago, reshaping the evolutionary trajectory of life on Earth. The next gamma-ray burst to threaten our planet might not occur for millions of years, or it could happen tomorrow. Space provides no guarantees, only probabilities, and the sobering reminder that our planet's peaceful existence depends on cosmic circumstances largely beyond our control. In the grand theater of the universe, gamma-ray bursts are the ultimate scene changers. Cosmic events so powerful that they can rewrite the biological history of entire worlds in the time it takes to snap your fingers. As we gaze up at the stars, we're looking at a universe filled with these sleeping giants, any one of which could wake up and remind us just how fragile our existence truly is. The universe has been relatively kind to Earth so far, keeping the most violent explosions at safe distances. But gamma-ray bursts serve as a humbling reminder that our planet's story could end not with a whimper, but with a flash of light traveling at cosmic speeds, a final, brilliant punctuation mark written by the stars themselves.